أعزائي الطلبة طلبة أولى ثانوي، السلام عليكم ورحمة الله وبركاته. أهلا بكم في درس جديد من دروس التريج. درسنا النهاردة Trigonometric Identities. First definition: the identity is an equality and it's true for all real values of the variable. For example, sine pi over 2 minus theta equals cosine theta. It is true for it's true equality for all real values of theta, and you have to take care of this. In the identity, it is true equality for all the values of theta, whatever the value of theta. Theta equal pi over 3, pi over 4, pi over 5. It's always true. But we have another definition for the equation. Is a true equality for some real numbers which satisfy this equality. For example, sine theta equals half. It's true only for the values of pi over 6 and 5 pi over 6. Note that theta belongs to this interval 0 to 2 pi. So there is a difference between the identity and the equation. The identity, it is always true for all values of theta. But in the equation, it's true for some values of theta, which satisfy this condition. Sine theta equals half. Sine theta equals half when theta equals pi over 6 in radian, or 30, or 150 in degree measure. 5 pi over 6 in radian equivalent to 150. So sine 150 equals half. Sine 30 also equals half. So the equation, according to the definition, the equation is a true equality for some real numbers. Now we'll take some examples. Try to solve one. Which of the following relations represents an equation and which of them represents an identity? It's clear that cosine theta equals root 3 over 2. Cosine theta equals root 3 over 2. It is equation because it's true for some values of theta, not all the values of theta. But tan 3 pi over 2 plus theta equals the negative cotan theta. It is identity, and we can say about it, it is true for all the values of theta. Cotan theta equals negative 1 over root 3. It is an equation. Sin pi minus theta equals sin theta. It is identity because it is always true for any value of theta. And we can write the solution here. A, an equation. Here, it's equation. B, an identity. C, an equation here. And D, an identity. Simplifying the trigonometric expressions. A, write the simplest form of sine theta plus cosine theta all square minus 2 sine theta cosine theta. The required here is to write this expression on its simplest form. Solution: the expression sine theta plus cosine theta all square minus 2 sine theta cosine theta equals, we expand this bracket, it will be sine square plus cosine square plus 2 sine theta cosine theta, and we write it Again, the first square will be sine square. The second square, second term, square equals cosine square. Third term, it is the middle term, first by second by 2. So it will be 2 sine theta cosine theta minus 2 sine theta cosine theta. Now 2 sine theta cosine theta minus 2 sine theta cosine theta equals 0. We can cancel it. So the remainder will be sine theta, sine square theta plus cosine square theta, sine square theta plus cosine square theta, which equal 1. So the simplest form of this expression is 1. B. Write in the simplest form 1 plus tan square theta over 1 plus cotan square theta. Always we try to change the expression to another form in sine and cosine, in sine and cosine as possible. Solution: 1 plus tan square over 1 plus cotan square equals 6 square over cosec square. As you know, 1 plus tan square equals 6 square theta, and 1 plus cotan square theta equal cosec square theta. You have to memorize these rules and how you deduce it from Pythagorean rule. You know, Pythagorean rule is sine square plus cosine square equals 1, and you can deduce that 1 plus tan square equals 6 square, and 1 plus cotan square equals cosec square. Now we change this form to sine and cosine. 6 square theta equals 1 over cosine square theta. Divide, we write divide. Cosec square theta, it is 1 over sine square theta. Because the reciprocal of sine square theta is 1 over cosec square theta. So cosec square theta equals 1 over sine square theta. And we change the division to multiplication, multiplying by the multiplicative inverse of 1 over sine square theta. It will be sine square theta over 1. So we have 1 multiply sine square, it is sine square. Cosine square multiply 1 equals cosine square. Sine over cosine equals tan. So sine square over cosine square equals tan square theta. So the simplest form of this expression is tan square theta. Put each of the following expression in the simplest form, then check the result. Okay, 1 over cosine square theta minus 1 over cotan square theta. Solution. First, we have to memorize these rules. Cosine square plus sine square equals 1. Dividing both sides by cosine square, you will get the first rule. 1 plus tan square theta equals 6 square theta. Dividing both sides by cosine square. Cosine square divided cosine square equals 1. Sine square divided cosine squares equals tan square. 1 divided cosine square equals 6 square. And you can deduce another rule, dividing both sides by sine square. So we have 1 over cosine square minus 1 over cotan square. 1 over cosine square equals 6 square. Minus 1 over cotan square equals tan square. And 6 square minus tan square equals 1. So the simplest form here for this equals 1. Again, how we deduce this? We know that 1 plus tan square equals sec square. So sec square minus tan square equals 1. Sec square minus tan square equals 1. So the simplest form for these two fractions is 1. And you can check your answer using some values to theta, not all the values of theta, because this is equation, not identity. B cosine pi over 2 minus theta sec pi over 2 minus theta. We want to write it on the simplest form. Cosine pi over 2 minus theta equals sine theta, multiply sec pi over 2 minus theta equals cosec theta. But cosec equals 1 over sine. So sine theta multiply 1 over sine theta equals 1. So the simplest form for this is 1. If you choose theta equals pi over 2, you will get sine pi over 2 multiply 1 over sine pi over 2 equals 1. Pi over 2, it is 90. Sine 90 multiply 1 over sine 90 in your calculator equals 1. It's true for some values of theta because it is equation. See? Sine pi over 2 minus theta over cosine 2 pi minus theta equals sine pi over 2 minus theta equals cosine theta. Cosine 2 pi minus theta equals cosine theta. It's fourth quadrant. Cosine theta over cosine theta equals 1. So this is the simplest form. Of course, you cannot put theta equals pi over 2. It is equation, not identity. But you can check your solution using any value of theta, 60, 30, for some values only. Example 2. Prove the validity of the identity cosine square theta over 1 minus sine theta equals 1 plus sine theta. You know that cosine square theta equals 1 minus sine square, because cosine square plus sine square equals 1. It's a very important rule. We write it, remember it, sine square theta plus cosine square theta equals 1. So cosine square theta equals 1 minus sine square theta. So we can use it in the numerator here in our solution. So left hand side, cosine square over 1 minus sine. Cosine square equals 1 minus sine square over 1 minus sine theta. You can factorize the numerator into two brackets. It's a difference of two squares. So it will be 1 plus sine theta multiply 1 minus sine theta over 1 minus sine theta. Then 1 minus sine theta over 1 minus sine theta equals 1. 1 multiply 1 plus sine theta equals 1 plus sine theta equals right hand side. The right hand side. This is identity. Example 3. Prove the validity of the identity tan theta plus cotan theta equals sec theta cosec theta. Solution. Tan theta plus cotan theta, it is the left hand side, we write it, equals tan, it is sine over cosine, cotan, it is cosine over sine, equals. How you add these two fractions? We write the common denominator of these two denominators, lowest common multiple, it is cosine sine. And then cosine sine, divide cosine equals sine. Sine multiply sine equals sine square. And we repeat it with the second fraction. Cosine theta, sine theta, divide sine theta equals cosine theta. and we multiply the result by the numerator equals cosine square. Don't forget, sine square plus cosine square equals 1. Sine square plus cosine square equals 1. So the result will be 1 over cosine sine, which equal sec cosec. 1 over cosine, it is sec. 1 over sine, it's sec theta equals right hand side according to the required. Prove the validity of the identity 1 minus sine square multiply 1 minus cosine square over tan square equals cosine power 4 theta. And we write it 1 minus sine square equals cosine square. 1 minus cosine square equals sine square over tan square theta. So in the first step, instead of 1 minus sine square, we write cosine square. Instead of 1 minus cosine square, we write sine square. Equals, we write the numerator, cosine square multiply sine square, divide, I write divide in this form, tan square, it is sine square over cosine square. And we change division to multiplication in this step. And we write the multiplicative inverse of sine square over cosine square. It will be cosine square over sine square. And now we can simplify sine square with sine square. So the result will be cosine square theta multiply cosine square theta equals cosine power 4 theta equals right hand side. Prove the validity of the identity 1 minus cotangent square over 1 plus cotangent square equals 2 sine square theta minus 1. Always we take left hand side, which equal 1 minus cotangent square over 1 plus cotangent square. 1 minus cotangent square, it is the same, but 1 plus cotangent square equals cosec square. Again, 1 minus cotangent square, we write it itself. 1 plus cotangent square equals cosec square. You have to memorize and you must deduce this. You must know how to deduce these rules. 1 plus cotangent square equals cosec square. But cotan equals cosine over sine. So cotangent square theta equals cosine square theta over sine square theta. What about cosine square? What about cosec square? Cosec square theta equals 1 over sine square theta. Always we try to change any function to sine and cosine, cosine and sine. So multiplying up and down by sine square, here multiplying up and down by sine square, so sine square multiply 1 equals sine square. Sine square multiply cosine square over sine square equals cosine square. Again, we multiplying up and down by sine square. So multiplying sine square over sine square. Sine square multiply 1 equals sine square. Sine square multiply this fraction, multiply cosine square over sine square equals cosine square. Sine square multiply 1 over sine square equals 1. So the denominator here will be 1. Okay? So the left hand side equals sine square minus cosine square. But the required here to be 2 sine square minus 1. So cosine square, we change it. It is equal 1 minus sine square. And we write it in one step. sine square minus 1 minus sine square. What is the value of cosine square theta? It is 1 minus sine square theta. So it is equal to sine square theta minus 1. Sine square minus 1. Here is minus 1. Minus multiply minus equals positive. So it is equal sine square plus sine square again. It will be 2 sine square theta minus 1 equals right hand side, and this is the required. Here prove the validity of each of the following identities. 1. Proves that 1 plus cotangent square over 1 plus tan square equals cotangent square theta. Start with A. We write left hand side, it will be 1 plus cotangent square over 1 plus tan square. And we write the main rules. 1 plus tan square equals sec square, and 1 plus cotangent square equals cosec square. We will use it here. Equals. Instead of 1 plus cotangent square, we write cosec square. 1 plus tan square equals sec square. Memorize it. And we change this fraction to division. Normal division. It will be, we write cosec square theta equals 1 over sine square theta. Divide sec square theta. Sec square equals 1 over cosine square. Then we change the division to multiplication. So the result will be cosine square over sine square, which equal cotan square theta equals right hand side according to the required. And don't forget, this is identity, so it is always true for all the values of theta. B. Prove that tan theta plus cotan theta over sec theta cosec theta equals 1. Left hand side equals this division. Tan theta plus cotan theta all divide sec theta cosec theta. This is only left hand side. Left hand side. Left hand side. So it's equal. We change tan and cotan, sec and cosec to sine theta. Most of problems you can solve it in this way, changing tan and cot, anything, change it to sine and cosine. Tan theta equals sine theta over cosine theta. Cotan theta equals cosine theta over sine theta. Divide sec, it is 1 over cosine. Multiply cosec, it is 1 over sine. So sine theta over cosine theta, it is the same. Divide 1 multiply 1, it is 1. Cosine theta multiply sine theta equals cosine theta sine theta. And we add these two fractions. The common denominator will be cosine theta sine theta, cosine sine, and the sine theta multiply sine theta equals sine square. Cosine multiply cosine equals cosine square. We change division to multiplication. Multiplication by the multiplicative inverse of this fraction. What is the multiplicative inverse of this fraction? It's cosine theta sine theta over 1. But sine theta cosine sine square plus cosine square equals 1, and you can cancel cosine theta sine theta with cosine theta sine theta. So the remainder will be sine square plus cosine square, and it is equals 1, and this is the required. C. sec theta minus tan theta all square equals 1 minus sine theta over 1 plus sine theta. This is the required to prove left hand side equals right hand side. Solution. Again, we'll use these equations. Sec theta minus tan theta all square equals, what about sec? It is 1 over cosine. As I told you before, most of these problems solved by changing sec and tan and anything to sine and cosine. So sec, you can write it 1 over cosine. What about tan? It is sine over cosine, all square. Here, what is the sum of these two fractions? It is 1 minus sine theta over cosine theta. We have here the same denominator, so we write it and we write 1 minus sine theta all square. This square, it is the same here, so it is equal 1 minus sine square over cosine square. 1 minus sine theta over cosine theta all square equals 1 minus sine theta all square over cosine square theta, like this. Here we have 1 minus sine theta all square equals 1 minus sine theta multiply 1 minus sine theta. It is the same bracket, not a difference of two squares. Cosine square theta equals 1 minus sine square theta. Why? Because cosine square plus sine square equals 1. So cosine square equals 1 minus sine square. What about 1 minus sine square? It's a difference of two squares. Again, we write it. So it is equal 1 minus sine. Multiply 1 minus sine, it is the same denominator. But here equals 1 minus sine theta multiply 1 plus sine theta. Because 1 minus sine square, it is the difference of two square. You can factorize it into these brackets. And now you can cancel 1 minus sine theta, and the remainder will be 1 minus sine theta over 1 plus sine theta, and we write it, it is the right hand side. And this is the end of the lesson. You can like, you can comment or subscribe if you don't.